The next conic section we're going to look at is the ellipse. It is a slice that is at an angle to the axis, which the axis would lie going through the center like this, the center of that right there. That would be the axis that we have right there. So it lies at an angle that's not perpendicular to the axis like this, and we get an ellipse. All right, define an ellipse in terms of the foci. Well, you can see here that the foci are these two pins. And this is a way to draw an ellipse. Now you take a string and then keep the string tight around the tip of the pencil, and if you draw each side of it, you get an ellipse. Now what stays constant is that no matter where you put a point on the ellipse, the distance or the string is going to stay the same length. So if you add this length and that length, or this length and that length, the sum is always equal to each other no matter where you pick that point on the ellipse. Those points will always, those lengths will be, the sum of those lengths will always be equal to each other. Where must the foci of an ellipse lie? Well, it makes sense now that once we know that this is what it does, that this distance is going to be longer than this distance, so we know that they have to lie on the major axis, no matter which direction it goes. What's the special case of the ellipse? What special case of the ellipse do we have when the major and minor axis are of the same length? Well, if they're the same length, that would mean that A equals B, so that means the distance from the center to the ellipse is the same. Now, the shape that creates that is a circle. Now, what happens to the focus, like in this question's asking? Well, that means that, remember, the focus is the sum is equal to each other, so that means that the 2 points then get squeezed on top of the center. So the focus and the center are actually the same point in a circle. We just call it the center. The two major and minor axes, we just call them the diameter, and then the distance is always the same, the radius. What can be said about the symmetry of a graph of an ellipse? Well, I don't know if it really centered at the origin along the y-axis. So it doesn't say which direction, but it doesn't matter if it's y or x. Notice that it's symmetric around the y-axis, it's symmetric around the x-axis. Doesn't matter which one is the major and minor. So it just is symmetric around the y-axis when you're at the center. But if I'm at just any old point, HK, we still have symmetry around the minor axis and the major axis, but it's no longer necessarily the x or the y axis. That's all. But we still have that same symmetry, it's just the major and minor axes have been moved some distance, h and k. Okay, let's try a few problems. For the following exercises, write the equation of the ellipse in standard form and identify the endpoints of the major and minor axis as well as the focus. So if we try this problem here, number 14, we're given 4x squared plus 16y squared is equal to 1. Now, standard form would be x squared over a squared, y squared over b squared, or x squared over b squared plus y squared over a squared, like that. Now, the book does it this way, where it always makes a greater than b, and this is why they do it. In my head, I just always remember the big number is the major axis and the smaller number is the minor axis, and then you don't have to worry about a's and b's. And if you know the distances and everything, you can always, figure stuff out without having to memorize stuff like this. But for this one, what I want to do is just rewrite the 4 in the denominator. So I'd write this as 1/4 plus y squared over 1/16 equals 1. That would give me a major axis of 1/2, right? That's the square root of 1/4. And I'd get b, which is the square root of 1/16, right? That would be 1/4. And so this is the direction, the major axis is in the horizontal direction. So if I want to find the major and minor axis endpoints, the major axis endpoints then are, well, the A is under the X, right, because that's longer, so that would be 1/2, 0, and 0 minus 1/2, because again our center's at 0, 0, and then this direction would be, our minor axis would be 0, 1/4, and 0 minus 1/4, like that. And where would our foci be? Well, we know that, right? So major axis was plus and minus 1/2, 0, and minor axis is 0 plus and minus 1/4. Those are the endpoints of our major and minor axis. Now, the relationship is that we know that c squared is equal to a squared minus b squared, like this, right? Or we could always do it as b squared is equal to a squared minus c squared. They just switch places, so whatever you're given, you can always just rearrange it, right? So if I plug these things in, I would get c squared is equal to 1/4 minus 1/16, which is 4/16 minus 1/16, which is 3/16. So c is square root of 3 plus and minus 4. So our foci are at, because they're on the major axis, would be plus and minus square root of 3 over 4, 0, like that. And that would give us our 3 answers that they want. Alright, so now let's try this one, number 20, which says 9x squared minus 54x plus 9y squared minus 54y plus 81 equals 0. Oops, I forgot the 4 there. 54y. Alright, now to complete the squares, what we're going to have to do on these pieces, I'm going to have to factor the 9 out. Or I could just divide everything by 9, since they are all divisible by 9, right? So if I divide everything by 9, I'm going to get x squared minus 6x plus y squared minus 6y plus 9 equals 0. So the one thing I know already, just by looking at this, is because we should be I think we'll get a circle, because these numbers are these are both 9s. If they were two different numbers, then we'd get the ellipse. But because they're the same sign, we know that they're either an ellipse or a circle. So before we even start, I'm pretty sure this is going to be a circle when we get done, right? So let's figure it out. So we have x squared minus x. Half of this squared is 9, plus y squared minus 6. Half of this squared is also 9. Subtract this over to the other side, and then add 2 9s. Those subtract out, so this factors to x minus 3 squared plus y minus 3 squared is equal to 9. So this gives us a center of 3, 3, and a radius of 3, like that. So we actually have a circle. But even if it was ellipse, we'd still do it the same way. The only thing I'd do different, if it was ellipse, I'd divide the 9 over, so I'd get x minus 3 squared over 9 plus y minus 3 squared over 9 equals 1, which is just another way to write the equation of a circle, actually, is to write it like this. Yeah, right? If these two are the same, then we know it has to be a circle. We could put an R in there, because that would be probably more appropriate, because then the R would represent our radius. For the following exercise, graph the given ellipses, noting centers, vertices, and foci. So we're supposed to be graphing this one. 16 plus y squared over 9 equals 1. Well, I know that the center is at 0, 0. Right? Because that's what's being subtracted from x and y, nothing. I know that the 16 is bigger than 9, so I know the major axis is 4. The minor axis length, well, I know that the distance from the center is 4. Right? So I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and 1, 2, 3. I can draw that in. So I get 4, 0, minus 4, 0, 0, 3, 0, minus 3. And then of course, my foci are going to be at 16 minus 9, which is, what, 7? So C is the square root of 7, so that would be, well, 7's bigger than 4, right? And less than 9. If I take, so square root of 7 is somewhere between 3 and 4. 1, 2, 3. So it's really out here somewhere. So this would be our square root of 7, 0, and this thing would be our minus square root of 7, 0. So if I'm given 40, this is 48. The center is at the origin, so the center is 0, 0. And it says symmetric to the x and y axis. Focus is at 3, 0. Right, our focus is at 3, 0. Our center is at 0, 0. The major axis is twice as long as the minor axis. Minor axis. So, what do I know? Well, I know it's in the x direction. I know it's at 0. So if I just try to graph it, here's 0, 0, right? Here's my x and y axis like this. I know that here at 3 is a focus. So I know that 9 is equal to a squared minus b squared. Now, the major axis is twice as long as the minor axis. So that would mean that a is equal to 2b, like that. So this would have to be a. Here's minus 3, and here's minus a, go in that direction. And this distance b. So if the whole distance is twice as long, because really that's we're talking about the minor axis. So if 2b is equal to 2 times 2a, notice then I just divide out these extra 2's and I still get that. Oh, sorry, did it the wrong side. That we get a is equal to 2b. Now I can just plug that in, so I get 9 is equal to 2b squared minus b squared. So 9 is equal to, well, this is 4b squared minus b squared, which is 3b squared. So this would mean that, divide that over, that b squared is equal to 3. So b is equal to the square root of 3. And then, of course, a has to be double that. So a has to be 2 square root of 3. Right? And now I can write down the equation. So I get x squared over a squared, and then y squared over b squared equals 1. So I get x squared over, that's 4 times 3, which is 12, plus y squared, which is 3. And we have our equation of the ellipse with the information. Now, we don't have to have we could just figure out the equation from the graph. So if we look at 56 here, we can see that it's going in the long direction, like this. Oops, terrible ellipse. Right, we have so all we need really is to figure out what these points are. So I would think, just by the picture, because it's a little fuzzy, that this is, that we have our, this would be 1, and this would be y equals 3. And so this looks like, and then so it looks like the endpoint's at 4, and the other one is minus 2. Now they should be the same, so that should be 3, because that's just 4 minus 1. And then 1 minus negative 2, that's also 3. So it looks like our A is 3. And then this one looks like it would go up to, well, 4. And this one goes down to 2, it looks like. So if I'm at 3 here, so this would be 1 and 1. So it looks like our B is equal to 1. Now that makes our center at the point 1, 3, right? Go over 1 up 3. So our center's at 1, 3. Okay, so I can write the equation like this: x minus 1 squared plus y minus 3 squared. A squared is 9, B squared is 1, equals 1. And I have the equation of my ellipse. Now I don't need to write the 1 there, so really I could write it like this, which is probably better, because really, why would I divide by 1? So this is probably the better way to write it. A bridge is to be built in the shape of a semi-elliptical arch and is to have a span of 120 feet. The height of the arch at the distance of 40 feet from the center is to be 8 feet. Find the height of the arch at its center. Oh. So this is 66. So we have a arch like this, which is to be 120 feet here. And then it says, so let's call the center here, we'll put it at 0, 0, just because that's the easiest. And then this is unknown. This distance, of course, is 60, because the center is halfway across, right? So our A is 60. We have that automatically. We have H and K, our center. That's 0, 0. Now, what we also know here is that a distance of 40 feet, right? So this is 40 feet. This is 8. There, like that. Okay. So how are we going to use that? Well, I know that x squared over 60 squared plus y squared over b squared has to be equal to 1, like that. Now I also know that this coordinate right here would be 40 over and 8 up. So I can plug in 40 squared over 60 squared plus 8 squared over b squared, and now I can solve for b. So I would get 8 squared over b squared is equal to 1 minus 40 squared over 60 squared, and then take the reciprocal of both sides. So I'd get 1 over this, and then I would multiply over by 8. So I'd get b squared is equal to 8 squared over 1 minus 40 squared 60 squared, which I suppose I could simplify it before I stick it in my calculator as get a common denominator. So you get 8 squared times 60 squared over 60 squared minus 40 squared. And at this point, then, I'm going to put it in my calculator. I get B is equal to 115.2. A person in a whispering gallery standing at one focus of the ellipse can whisper and be heard by a person standing at the other focus, because all the sound waves that reach the ceiling are reflected to the other person. If a whispering gallery has a length of 120 feet and the foci are located 30 feet from the center, find the height and the ceiling of the building. All right, so we have a whispering gallery, then ellipse. the span of this thing is 120 feet. And so that would make 60 and 60. So A is 60. Right? Now it says that 30 feet from the center, which would be halfway. So this is 30 and 30 right here. So that's C squared is equal to 30 squared, or C is equal to 30, right? So we know that 30 squared is equal to 60 squared minus B squared, or 60 squared minus 30 squared is equal to B squared. So we get 3,600 minus 900 equals 2,700. So B is equal to the square root of 2,700. Well, this would be 9 times 3 times 100, or 330 square root of 3. So the height of B is 30 square root of 3, which is approximately 51.961. Oops. 51.961, which is approximately 52 feet high.